Okay, so we're talking about the shape of data, and so we have two sets of tables here, and we're going to construct a dot plot for each table. So we take our points, and we're going to make a scale. So on the first one, the smallest number was 86, the greatest is 96, so I scaled from 86 to 96, and then we're going to plot a dot to represent each point. So the total number of points should have the same amount of dots here, so we make a dot to represent each point. Same thing here, the smallest number was 72, the greatest was 90, so we put the scale on. Again, we make a dot for each point. If there's more than one point at the same value, we're going to stack the dots. So then the question asks us to find the mean and median for student 1. And if you calculate the mean and median, they are both 91. Then for student 2, the mean is 84.35 and the median is 86. So the mean is less than the median in this case. So based on the answers from that, make a statement about the mean and median for skewed data versus symmetrical. So if we look at the data set here, it's symmetrical. Everything is equally distributed. Symmetrical data. Okay? And when we notice that, what happens to the mean and median when it's symmetrical? They are equal to each other. Over here, the data is not symmetrical. You can see a lot of the data points are over here, and there's a lot less this way. That is considered skewed, and it's skewed to the left side because that's where the tail comes. If you kind of think about this as a little mouse. So you have a little mouse with the whiskers, and the tail is this way. So that's skewed to the left side, which we also call negative. So it's negatively skewed, and in the case when it's negatively skewed, the mean is going to be less. It's going to go negative or be less than the median. Okay, so all graphs, when the data is skewed, the mean gets pulled away from the median. If it's skewed to the left, it's going to pull left and make the mean less. If it was skewed to the right, it would pull right and make the mean more. So we turn the page. There are directions telling you to create. So if at the top we look at the skew for a histogram, negative skew, again you see that tail on the left side. Symmetric is nice and balanced. It looks like a bell. And positive skew, the tail is on the right side. For example 1, it does say to use a graphing calculator. We're going to do this without a graphing calculator. So if you're graphing a histogram, you're going to take your points and you're going to kind of figure out ranges. So you may say my first data points are between 18 and 20, and then you might go 20 to 22 and so forth, and make some kind of scale and then find the values. So you're going to create your own histogram, distribute them and put them in groups. So you might want to go by 2s or 4s or 5s or whatever you want. And then once you draw your histogram, you should see that this is skewed with the tail in the positive direction, so positively skewed. On the next page, we have a box plot, and we look at the box plots that we talked about in the previous lessons. If you see more of the box to the left, the box is bigger on the left, the tail is bigger on the left, that's negative. The boxes are equal, the tails are equal, symmetric, and in this one, the box and the tail are bigger on the right, that is positive. Okay, so we're not going to do the box and plot. You're going to do the box plot by hand again, come up with a scale. It looks like the smallest number is 2. And the greatest number is 28, and you scale it out and then create it. And if you do that correctly, you should see a symmetric box plot. So if we turn the page along, what information can we tell from the symmetry of a graph? So when we're trying to figure out what data to represent the data accurately, we want to find the symmetry. If it's symmetry, the mean is the best way to represent the data. So we're going to give the mean as the answer when asked about the data representation. And usually we give the mean and standard deviation. Okay? If the data is skewed, the median better represents the data because the mean is skewed, it pulls away from the data. So if it's skewed, we use the 5-number summary to represent the data. So if we kind of look back to our previous examples, the first example was skewed positively. So for that data set, we wanted to find the 5-number summary. The minimum, Q1, the median, Q3, and the max. So we go back and find those values. Make sure you put the numbers in order to find those values. For the box plot, the data was symmetric, so we're going to find the mean and standard deviation, so you can calculate the mean and standard deviation. You don't have to go through and calculate these, but if you did, the mean would be 14.4, and the standard deviation is 6.98. So what you really want to focus on is if the data is symmetric, the mean is what you want to give as your answer. If the data is skewed, you want to give the 5-number summary, or more specifically, the median.